Reishi's Organic Chemistry Final Project wrap. About to drop it. Flows super well. Yo, check it. We got Organic Chemistry on the mic. You thought chemistry couldn't get any harder? Psych! We got everything from alkynes, alkenes, alkanes, and benzene. Up next, we got alcohols, phenols, thiols, and esters on the scene. Carbonyls, carbolic acids, esters, amines, amides, carbohydrates, lipids, you know what I mean? Amino acids and proteins at the finish line. You didn't know you could process all this information at one time. Organic chemistry, it has a few rules. Water and soluble organic molecules. Nitrogen, oxygen, and halogen are our players. Arrange them around a hydrocarbon and you got organic compound layers. You name the organic molecule by how many carbons are going on. Methane, ethane, butane, propane, pentane, hexane, the list goes on and on. We started with alkanes, kept it pretty simple, pretty much just hydrocarbons with some carbons in the middle. Moving on up to alkenes and alkynes, got some saturation happening on the carbon line. Mix things up with some addition reactions, hydrogenating and halogenizing to your satisfaction. Yo, check it out, because on alcohols, I got the scoop. They're just an OH molecule attached to an alkyl group. Making moonshine, you just need water, acid, catalyst, and an alkene. Mix those things together and get your buzz on, know what I mean? Or an aldehyde and hydrogen, mix those things up. Add some heat to dehydrate the alcohol and back the reaction up. Alcohols have lots of friends. They can oxidize to carboxylic acid so long as water and aldehyde are around and placid. Ethers are cool and easily catch fire. Can be made by dehydrating alcohols if that's what you desire. Thiols aren't that popular. They're kind of smelly due to the sulfur molecule, but they taste good in the belly. Aldehydes and ketones got those carbonyls in them all, made by primary and secondary oxidation of alcohol. Reverse this reaction by reducing with hydrogen. Get those aldehydes and ketones back to alcohol, amen. A hydroxyl group and a carbonyl can combine to make a carbolic acid right about time. Can be produced by a primary alcohol or aldehyde, but only in the presence of water by its side. They can dissociate into alcohols or base hydrolyze into salts or even decarboxylate. It's the high temperature's fault. Mix them with an alcohol and you'll produce an ester, plus a carbonyl ester. Ether is its ancestor. Reverse the reaction, hydrolysis, yo. An ester and water make carboxylic acids and alcohols go, go, go. Saponification is pretty fun. Break the fatty acid into glycerol. Carboxylic acid salts you win. Amides and amines, here's what you gotta know. Amines can act as a base, but amides never so. Carbohydrates have got it going on. I need my beat back. Alright. Carbohydrates have got it going on. They can involve stereochemistry. That list goes on and on. An important carb is glucose. Know its Fisher and Hallworth projections. Be able to link sugars together and link their alpha-beta intersections. Lipids are fats, and man, they taste good. They act as energy sources and provide insulation just as they should. Fatty acids, glycerides, waxes, and complex lipids are all in the mix. Fatty acids is the reagents of saponification and all its kicks. Last but not least, we got amino acids and proteins. Pretty important as the building blocks for DNA, you know what I mean? Alright, that's all I got, all of organic chemistry in one single wrap. If you think I covered too much information too quickly, well, that's the course in a recap.